In this video, we'll be discussing simple probability. Simple probability consists of one event, and it is calculated by dividing the number of outcomes over the number of possible outcomes. So let's look at some examples. Our first example is Robbie rolls a six-sided die. What is the probability, or P, you could see it as just written P, that he will roll a 2. Now, if you think of the numbers on a die, there's 6 of them. There's a 1, a 2, a 3, a 4, a 5, and a 6. And it says Bobby rolls a 6-sided die. What is the probability he will roll a 2? So I want the probability of a 2. So the outcome that I want is a 2. So how many outcomes are a 2? Well, only one outcome is a 2, but there are 6 possible outcomes. So our answer is 1/6 in this case. 1/6 probability of rolling a 2. If you look at example number 2, June wants to read a Shakespearean comedy. Shakespeare wrote 6 comedies and 12 tragedies. What is the probability, P, that she will select a comedy? So, I want the probability that she will select a comedy. So, the number of possible outcomes, well, how many comedies are there? There are 6 comedies. So 6 are the outcome that I want out of how many possible outcomes. Now, because there are 6 comedies and 12 tragedies, you need to add them together to find the total, because this is comedies and related to total. If you add those together, you get 18. Now, the question is, can I simplify that? I can simplify this by 6 or by 2 a few times, and I'll end with 1/3 probability of choosing a comedy. Our last example, it says Carly randomly chooses a card from 20 cards. There were 10 blue, 1 green, 3 yellow, and 6 red. What is the probability that she will select a red or a blue card? So I want the probability that she will select a red or a blue card. Now, I don't care if I choose red or blue. It doesn't matter. So how many cards total do I have to look at for my outcomes? Well, I have 6 red and 10 blue, which would be 16 total cards that I can choose. So it's 16 out of the total, which they tell me there's 20. So 16 out of 20. I can divide this by 4. And I'm left with 4/5 probability. Okay? So for the OR ones, you have to add the numerator to the 2 pieces of the numerator together to find out how many total outcomes. I don't care if it's red or blue, it could be either one, but I have to figure out how many outcomes I have. So let's look at these last 2 examples. The faces of a fair 6-sided cube are numbered 1 through 6. The number cube is rolled. What is the probability it will land on an even number? Now, remember your even numbers. I'm going to write them out. Are a 2, a 4, and a 6. So I want you to try to write out the probability it will land on an even number. Why don't you try that one by yourself? So our probability of landing on an even is 3, because 3 of them are even out of 6. And then you can divide the numerator and denominator by 3, and you're left with 1/2 probability. Or you could also write it as 50% probability. Number 2, a standard 6-sided number cube is rolled. What is the probability a 3 or a 5 will land face up? So I want the probability of a 3 or a 5. If you need to, write out the numbers that are on a die. Try this one on your own. What's the probability of a 3 or a 5? Okay, so here's my 3, here's my 5. I don't care which one I get. It can be either or. So I can get 2 out of 6, and you should have simplified that by 2 in the numerator and denominator, and you got 1/3 probability. All right, let's look at the next page. So the pieces of candy in Paul's bag of candy have the following colors: 40% red, 30% blue, and 30% yellow. If Paul's friends selected a piece of candy at random today, what is the probability that he will select a red piece of candy? Now, this can be a very simple problem. I want the probability that he will select red. Probabilities can be written as fractions. They can also be written as percentages. Very easily, I can see that 40% are red, so simply writing 40% would be a correct answer. But if we were to write this as fraction, percents are always out of 100, so this would be 40 out of 100. They end in 0, so I can divide by 10, but I know I can also divide these by 20 to simplify. And I'm left with 2/5 probability. So both of these answers are correct answers. 2/5 would be the simplified fraction, and 40% would just be the percentage. Let's look at number 4 together. The following number cards are in a lottery box. The number can be drawn at random from the lottery box. What is the probability of drawing a 10, a 12, or a 14? Now, I don't care which one I pick. It could be a 10, a 12, or a 14. So, how many choices do I have to pick? 3. Out of how many total cards are there? I have 20 cards in the lottery. Can that simplify? No, it cannot simplify, so 3/20 is the answer. All right, I want you to try number 5, 6, 7, and 8 on your own. When you're ready, unpause the video and I'll go over them with you. Okay, and here are your answers for 5, 6, 7, and 8. For 5, there are 25 total. 7 of them are purple. In number 6, be careful they didn't number the spinner in a conventional way. So there's only 1 out of 4 that are an even number. Number 7, it wanted red or green. I don't care which one is picked. It just has to be red or green. So there are 7 total out of 10. And then for number 8, it says the probability it will land on a shaded square. There are 13 shaded squares out of 25 total squares. All right, so go ahead. I want you to try number 9 and number 10. They're a little bit tricky, but I want you to try them on your own. Unpause the video when you're ready to review them. And here are your answers for number 9 and 10. Number 9 was tricky, just like the first example that we did up at the top. They gave you the percentage, so you could have just written 40%, or you could have turned the percent into a fraction and gotten 2/5 of the students were boys. And then the last one, he's working on free throws. 54 make it out of the 72 shots he took, and it says based on this ratio, what's the probability of this next shot going in? You had to simplify down the ratio that they gave you, and you got to 3/4. Now, one thing that's very important with this unit is highlight or underline or circle what the problem is actually looking for. If you do that, you're less likely to make a mistake.